Inside the glowworm caves, the living galaxy beneath New Zealand. Imagine stepping into total darkness. No city lights, no moon, no sound except water echoing through stone. Then slowly, above your head, tiny blue lights begin to appear. Hundreds, thousands, tens of thousands. It looks like a galaxy trapped underground. Welcome to the Waitomo Glowworm Caves in New Zealand, one of the most surreal natural wonders on Earth. But what you're seeing isn't magic, it's hunger. The glowworm that isn't a worm. The glowworm that isn't a worm. Despite the name, glowworms aren't worms at all. They are the larvae of a fungus gnat called Arachnocampa luminosa, a species found only in New Zealand. Their life cycle is short and intense. They begin as eggs laid on cave ceilings. When they hatch, the larvae build silk nests and hang down dozens of sticky threads, some reaching nearly a foot long. These threads act like fishing lines. The blue glow you see? That's bioluminescence produced by a chemical reaction inside a specialized organ in their abdomen. The light attracts insects flying through the cave's darkness. Moths, midges, mosquito-like insects. Drawn to the glow, they collide with the sticky strands and become dinner. The brighter the glowworm shines, the hungrier it is. In fact, when food is scarce, they intensify their light output to increase their chances of catching prey. Beautiful, but deadly. What do glowworms survive on? Glowworms feed primarily on small flying insects carried in by cave air currents, aquatic insects emerging from underground streams, even other glowworms if food becomes scarce. Yes, they are cannibalistic. If one larva wanders too close to another's silk threads, it can become trapped and consumed. In a nutrient-poor cave system, survival is ruthless. After about 6 to 12 months as larvae, their longest life stage, they pupate. As adults, they resemble delicate mosquitoes. And here's the tragic twist. Adult glowworms do not eat at all. They live only a few days, just long enough to mate and lay eggs before dying. Their entire glowing childhood is preparation for a brief adult finale. The Waitomo Caves are made of limestone, formed over millions of years from ancient marine fossils when much of New Zealand was underwater. Rainwater, slightly acidic, slowly dissolved the rock, carving vast chambers and underground rivers. But the glowworms aren't alone down there. The cave is its own ecosystem. 1. Cave weta. One of the most common residents is the cave weta, large, cricket-like insects with long antennae and powerful legs. Unlike glowworms, they don't produce light. They scavenge organic debris, fungi, and smaller insects. At night, they sometimes leave the cave to feed and return by morning. 2. Spiders and harvestmen. Various spider species inhabit the darker corners, feeding on insects drawn in by the glowworms. Some even compete directly for the same prey. Harvestmen, often mistaken for spiders, also roam cave walls in search of food. 3. Cave beetles. Tiny beetles live among damp rock crevices, feeding on decaying organic matter washed in by underground streams. They help recycle nutrients within the cave system. 4. Microbial life and fungi. Moist limestone surfaces support bacteria and fungi specially adapted to darkness. Some fungi break down organic debris, providing nutrients that sustain the entire cave food web. 5. Underground fish and eels. In certain connected cave systems across New Zealand, freshwater species such as longfin eels travel through subterranean waterways. These waterways bring in nutrients and insect larvae, indirectly feeding the glowworms above. Bioluminescent insects exist in other parts of the world, including fireflies and certain cave-dwelling gnats in Australia. But what makes Waitomo extraordinary is scale. Thousands of larvae cluster together on cave ceilings, creating a concentrated star field effect that feels cosmic. The caves also maintain stable humidity and airflow, perfect conditions for the larvae's delicate silk threads to remain intact. Too much airflow and their sticky lines dry out. Too little, and fewer insects drift through. It's a perfectly balanced system. The caves were first explored extensively in the late 1800s by local Maori chief Tane Tinarau and English surveyor Fred Mace. For the Maori people, Waitomo is not just a tourist site, it's a sacred ancestral place tied to the land and water. Today, Tours are often guided by descendants of those original explorers. Visitors float silently by boat through the glowworm grotto, no photography allowed, preserving both the darkness and the delicate environment. Even whispers are discouraged, because vibrations and light pollution can disrupt the larvae. What are glowworms used for? Glowworms don't exist for us, but humans have found value in them. 1. Ecotourism. The caves are one of New Zealand's most famous natural attractions, supporting local communities. 2. Scientific research. Bioluminescence studies help researchers understand chemical light production, which has applications in medical imaging, cellular biology, genetic research. 3. Environmental indicators. Glowworms are sensitive to pollution and climate shifts. Changes in their population can signal ecosystem imbalance. They are tiny but scientifically powerful. Despite their beauty, glowworm colonies are vulnerable. Changes in carbon dioxide levels, artificial lighting, human traffic, water flow, temperature can all impact their survival. If conditions shift too much, the lights simply go out, and once gone, they don't easily return. The glowworm caves are a reminder that nature doesn't need the sky to create stars. Deep underground, in complete darkness, life found a way to create its own light. But that light exists for survival, not spectacle. It's hunger glowing in the dark. And when you float silently beneath that living galaxy, you're witnessing something both breathtaking and brutally honest. Even beauty can be a trap. If you enjoyed this deep dive into one of Earth's strangest ecosystems, let me know what mysterious place we should explore next.